Welcome back. Let's answer this problem related to quantum numbers. And quantum numbers describe the behavior of electrons as well as give us a probability of where to find one in an atom. Let's just go over in the order presented in class without going into all the detail. The first quantum number presented was the principal quantum number that tells us the size and the energy of these orbitals, these clouds of probability of finding electrons. So the farther the electron is away from the nucleus, then the more energy that electron is required to have to be out there. So hence the orbital is larger. The next one is the angular momentum quantum number that tells us the shape of the orbitals. So we learned that there are s orbitals that are spherical, p orbitals that are dumbbell looking things, and then d and f orbitals are they get more and more complex. These are all solutions that come out from the Schrodinger's equation. And then the third quantum number we learn is m sub l. That tells us the orientation of these orbitals in three-dimensional space. So how many different orientations you have? You have one s orbital, three p orbitals, 5d orbitals, and 7f orbitals at energy levels where they have them. And then finally, the magnetic spin quantum number, and oftentimes we'll use some opposite convention like -1/2 and +1/2. An electron spinning one way will produce one kind of magnetic field, and spinning the opposite way will produce another one. So we're not likely to ask you this question on any kind of test. Rather, we're much more likely to tell you the quantum number and ask you to describe it, if anything. So we would give you like the principal quantum number and ask you, well, what does that describe? And then you would say the size or the energy or the distance or the radius of that orbital. Okay, so kind of the reverse of what we're asking you in this problem. All right, so the orientation, let's go right to the answers now. The A, orientation, that's going to be the magnetic quantum number. The size of the orbital is the principal quantum number. The magnetic moment or the spin, well, that's the magnetic spin quantum number, and the shape is the angular momentum quantum number.